Ladies and gentlemen, today's topic of discussion is a very broad term, and nowadays it is everywhere, just called as data science. Now, there is an intention behind that why at all I brought this thing in today's discussion for the international conference. See, because without knowing the fields which are relevant to data science, data analysis, data analytics, you cannot complete the research in all respects in today's era. Like, as a researcher, it is mandatory for you people to navigate through this concept which is called as data science, and knowingly or unknowingly, as a researcher, you don't know that you have to come across this term as a data science, and you cannot afford to bypass this term and do your research. So this is the importance of this domain of data science. So I'm going to throw some light on that particular domain, so that various participants, like I can see there is more than 90 participants who are listening to me, they also can come to know about what is data science and how they can implement data science in their own research. So that we are going to explore today. So let us start the exploration towards data science. So let's first try to understand what actually data science is, because it's a very modest terms nowadays, and maybe utilized everywhere nowadays. So data science is a multidisciplinary domain. So see, the purpose of introducing this topic is satisfied in the line number one itself, because we are talking in a multidisciplinary conference, and when I have to give a message which is global and which should be generic in nature, I think data science is correct topic to switch on with. So data science is a multidisciplinary domain that combines statistics, mathematics, computer science, and some domain specific knowledge to extract insights and knowledge of the data. Now let's try to understand the keywords which are there. See, it covers statistics, mathematics, so there is a narrow difference between the two terminologies. We know that. And computer science and domain specific knowledge, maybe like domain specific, when you're saying that if you're doing some drug discovery, some research in some pharmaceutical field, or maybe some research in supply chain management, so that is domain specific knowledge where we want to do wonderful things. Now for these all fields, if you want to extract insights, that means if you want to extract some truthful facts about the data, some intellect from the data, from knowledge from the data, then you are in the field of data science. So the mean to say is that, in summarized, you are having bulk of data with you, and you are trying to get the some intelligent summary out of that, some intellect out of that. That means you're dealing in data science. And I think this is the need of every research. You keep on doing research, you keep on doing literature surveys, and at the end of the day, you're trying to find out some of the glimpses of it, that what actually this research is all about. So if you're doing something like that, that means you are in the domain of data science. Now it involves collecting, analyzing, and interpretation of the data to solve complex problems which are driven by information. Now, collecting means what, analyzing means what, and interpretation means what. I'm going to tell you in the coming slides, because these all keywords are very, very crucial keywords when you are implementing operations using data science. But believe me, guys, all the manipulations or all the operations which you're doing in data science are data driven. So data is a very key point. Now, why should so I am saying this? Because data, when you are collecting it or when you are inputting it into the system, it has to be genuine and relative to your research. That is important. If the data is not relative to your research, then your research may come up with faulty results. That is also a possibility. So we need to take care of that. So yes, collection, analyzing, and interpretation of the data is crucial in data science, especially to solve complex problems. When I say complex problems, I means the problems are not that simple to solve. They are complicatedly organized, as if like somebody asking you that, hey, you have to develop a building of say 100 floors, which will be connecting to other buildings. This building should not be, get disturbed with earthquakes and all the floods, etc., etc. So there are number of things, there are number of conditions in the problem. Then the problem becomes complex problem. So if you want to solve that, you need data science. Now, if you are using data science, then what might be the opportunities which you can explore inside the research? So see, data science basically is an art and science of extracting valuable information. Now, when I say this, I mean I have a big bank of data, big collection of data. And now this big collection of data should lead to some intellect. It should lead to some fact finding, and whatever the intellect I extracted, whatever the facts I extracted from the data, they are helping me in decision making. So maybe I am a government, I am a business maker, I'm a banker, I'm a defense agency. So I accumulate huge data with me, and I will be fetching some facts, some intellect out of that, and I'm using that intellect in my work. So this is the beauty of data science, which it can easily enables. It encompasses wide range of techniques, including data collection. We heard about it. Pre-processing, very important step. Exploration of the data, modeling of the data, deployment of predictive models to uncover hidden patterns, trends inside that which can form business decisions and other applications. Let's try to understand each keyword over here. See, one keyword over here comes pre-processing. You need it when you're processing the data. You need it because your data which you have gathered, it may be primary data or it may be secondary data. Whichever the data you have gathered, both the data needs refinement. They need filtering so that they becomes ready to process by your model. So your model may be evolved from an algorithm, or maybe from a mathematical model, or maybe by a statistical method like heuristics and all those things. So you need to pre-process the data, you need to normalize the data. That is important. Now, why all these things are done in data science? To undiscover or to uncover the hidden patterns. Now, hidden patterns are the patterns which are not yet explored. Say, for example, what or how COVID-19 can perform on a human body, it is not yet explored. And if you really want that, hey, what are the implications of COVID-19 on human body? If you want to, get the grooves of it, then data science can help you. Insights that can be formed, business decisions. So if you are a business maker, if you are a businessman, and say, for example, you are going for a mobile manufacturing company, so you need some data science help, by virtue of which you can start taking decision that what is the production limit which you need to raise to a certain extent for coming days. Say, for example, what is the productivity which you have to have in 2025. So to predict these sort of quantities, data science can help you in great deal. So these are the various opportunities which we have to see about data science, and in coming slides we are going to explore them in detail. Now, when you talk about data science, then what is the working methodology? What is the entire process of data science? Initially, you have to start identifying your problem. Now, what I mean of problem identification, see, when you have to solve a complex problem using data science, you need to narrow down about your problem. Because when you narrow down about the problem, when you become very typical, very, very specific about the problem, then you can always invite the typical data concerning to the solution of the problem. So it is very mandatory that you will clear cut identify the problem definition, which is non-ambiguous and clear in nature. So while identifying the problem, what you need to do, you need to clearly define the business problem or questions to be answered using your data. So you should be knowing what exactly is the aim and objective of your research. And by virtue of research and incepting the data science, what sort of problem you want to solve. You have to have a clarity in your mind about your problem. And when you're solving these sort of problems, you also do, I mean, it's a recommendation from my side. You can also do a sort of a feasibility study. The feasibility study, which will be motivating the scientific quotient, which will be motivating the technical quotient, that this problem which I undertaken in the research, and I'm trying to crack by using data science, whether it's really technically feasible to implement that problem. So you should be analyzing all these things in problem identification. Now, once you know that, okay, this is my problem, this is what I want to crack, then comes the relative data collection. So the second step is about data collection. So you need to gather the relevant data. So relevant is a keyword over here. See, you have to gather the relevant data from various sources. ensuring the quality and accessibility. Again, two important keywords: quality and accessibility. So you know what is the research problem you have to solve, and you've gone for data collection. Maybe some of the scientists or some of the researcher can go for the primary data collection, where he's floating the Google forms, or maybe taking the surveys or interviewing people, and getting their feedback, so that what is to be done and what is not to be done. And maybe sometimes to having some data banks, some data resources. From that also you can gather the data, like there's Kaggle and there's WHO and whatnot. So they are also the data resources from which you can fetch the data. Now, the two important issues you have to look after when you're collecting the data, or when you're downloading the data, you have to see the quality and accessibility. See, sometimes the quality of the data which is relevant to the problem is not good, or is not impeccable. So what are the negative side of that, or what are the hazards it can produce to your research is that, see, if your data is not impeccable to your research problem, or it is not relevant to your research problem, then it may lead to falsify the results of your research. That is very dangerous situation to address, because then your research is of no more use to make any result analysis with the existing systems. So you need to make sure that your data is very intact, and very relevant to your research problem, and it possesses the sheer quality which you're looking after. And then comes the question of accessibility. Now, sometimes some agencies which are carrying the data or having the data don't allow their data to be, get compromised with somebody else, or they don't allow you to access their data. So you need to look after all these possibilities, where from I can get it. Maybe sometimes you have to reach the agencies. You can convince them about your research, and how it will be fruitful also to them. Make a win-win situation and get access of that data. So these are all the things which you have to obey while data collection. One thing for sure, whichever the data you're collecting, please give the due credit to all the authors or all the data sources. So once you're knowing about problem, you collected the significant data which can help you to design the solution. Now you have to start processing the data. Now, to process the data, you need to clean it. When I say clean it, I mean to make data normalized, or I mean to take out all the unwanted data from the already downloaded data set, and then you have to transform it. Now, transform means, see, data, the raw data which you can gather or you can download, maybe of any format, right? So you have to bring that in some significant structure, in some bottleneck, and then your model or then your software start processing that data. So it is your responsibility to bring the data in some shape, right? And then you can go to the machine and ask it to process and prepare the data for the analysis. Certainly. So when you're giving the data to analysis, there are certain models which require certain sort of inputs. Like there are some models who can always or can only process JPEG images, or PDF images, or something as that. So you have to convert your data into that particular format and then give to the system for the analysis. So these are all the working paradigms, working steps in the data science. Now, what happens in these working steps in detail? So we are going to see each and every step. The first and foremost step, as we talked about it earlier as well, that is data collection. So you have to gather the data from various resources, maybe sometimes databases or APIs. API stands for application programming interfaces. So you can always, inherit APIs, and also there is a web online portals which are available to you. They are nowadays having huge data. I will be trying to spend a minute on this. You can always get the data from very generative, very much utilize generative AI tools nowadays. You can always use somebody called ChatGPT. You can always use some tool called Microsoft Copilot or something as that. So these are all very handsome tools, and yes, you need to take care about the quality and the originality of the data. But if you know how to tackle them, how to handle them, they can help you in a great deal. I mean, they can help you to complete your research in very fast time, in quick fast time. Now, the second step is data cleaning, where you have to handle the missing values. So it happens sometimes when you download the data, all the fields which are expected to have the data might not be there. So you need to allow null values over there. You need to assign null values over there, and then you can fill those columns or rows which are blank, or otherwise you simply discard them if there are some important values which are missing. Remove the duplicates or the anomalies and address inconsistencies in the data. Yeah, if the data is not consistent, it is your responsibility to make it consistent, right? Feature engineering, which is the part of data science, create new relevant features from the raw data to improve the model performance. Now, this is where your metal as a researcher will be checked while deciding the features of the data. See, you collected the raw data, fine. Now you have to analyze that this raw data will be addressing which feature of my research, whether it's efficiency, whether it's precision, whether it's correctness, whether it's time, whether it's mobility, etc., etc. So you have to decide the feature from the collected raw data, and upon those features, you have to address your research. So this is what is expected from a researcher. Now, by using data science, you can always do exploratory data analysis. Now, what it actually means. See, when you are showcasing the data in graphic manner or your research in graphic manner, it impacts a lot. I mean, I think there are 106 researchers which are listening me. Guys, if you really want that your research manuscript should be selected by a Scopus journal or by a CI journal or a Web of Science journal, then exploratory data analysis is mandatory. And this is my personal, experience. If you are if you are narrating the graphical story about your data analysis, then the chances of selection of the paper is very, very high, provided your data is genuine, and your research produces the unique outcomes. So if these two properties are satisfied, I think no journal can reject your paper. In exploratory data analysis, we have visual data. So to express visual data, you can use charts, graphs, you can plot the diagrams. You can also show the relations using entity relationship diagrams or etc. etc. So visual, I mean, expressing the data is extremely important. Identifying trends, yes, by exploratory data you can identify the marketing trends, the pricing trends, the trends of the production of a certain unit, whether it's growing or shrinking or where it's heading towards. Even you can predict several things by identifying the trends. And by using exploratory data analysis, you can always go and generate hypotheses. Now, in case of hypothesis, we know that it's a statistical method by virtue of which you can decide that whether my research is heading towards in a proper direction or not. So you can have your null hypothesis and alternate hypothesis, and by some graphical way, you can show that yes, my research is heading towards in a proper direction. So these are all the advantages of data science when it is used for exploratory data analysis. Now, data science also used to employ machine learning algorithms to understand the data. See, as I started in this first slide itself, I told you people that if you're using data science, that means you're trying to extract the intellect out of the data. And to extract the intellect, you have to operate various algorithms on the already downloaded data or inputted data. Now, which are various algorithms? The algorithms are machine learning algorithms. See, what are the machine learning algorithms which you can employ in data science? The first is regression. Now, in regression, you can predict the continuous target variables based on some input features. See, regression is a relativity between dependent variable and independent variable. So, if you keep on providing some input variables which are independent, then how that will at all impact onto the dependent variable? That means the output variable. The analysis of that can be provided by regression. For example, let's listen this. For example, I expended 10,000 rupees for promotion of my X unit, which I used to produce. So I am planning that if I am enhancing those 10,000 rupees to 20,000 rupees next year, how much higher my units will be sold in the market. So that sort of analysis can be given by regression. So there is a relativity between dependent and independent variable or input or output variable. Then next algorithm which you can employ in machine learning for data science is classification. See, in classification, you can segregate the data into various classes. You can divide the data into various classes. For example, let's consider that you want to segregate all your email inbox into the emails which are very important and into the emails which are of not important. Okay, so you can do classification by using various classification algorithms of machine learning in data science. The next is clustering. So this is another algorithm which we can deploy using machine learning. Now in clustering, the important thing is that you keep on forming the clusters of similar kind of data. I can give an example that whether you want to identify, whenever you want to identify that whether a patient is suffering from COVID-19 or not, you can keep on gathering the data which is having similar symptoms of a patient which is prone towards COVID-19. For example, if a patient attributing or featuring that he is having fever, he's having headache, he's having cough, and his immune system is very weak, then you can categorize all these. You can collaborate all these features into a cluster which is prone to COVID-19 disease. And if a patient is only having fever and headache, but not having sneezing, cough, and immune system is quite okay, then he is not prone to COVID-19. So by virtue of this, you can do data analysis and some intelligent information coming to you that which patient may be COVID-19 infected and which patient should not be. So these are all the things which you can do in clustering. Then we'll see deep learning. See, deep learning is the evolution of machine learning, which is advanced part of machine learning. In deep learning, you have various neural networks, like artificial neural network is there, convolution neural network is there, and there are number of levels of the neural levels are there which are very dense and very high. So you need to model them, you need to weight them, you need to train them, and they used to produce very beautiful results. Deep learning techniques even better than machine learning. So you can deploy all these algorithms in data science, and these algorithms are functionable on the collected data, which we have already seen in step number 1 in the data collection. So deploy these algorithms on that data and extract the intelligent information. This is the motto. And you can use this intelligent information anywhere. You can use it in agriculture, you can use it in pharma, you can use it in business development, you can use it in banks, etc., etc. Then how a model which you have designed, the software model of data science which you have designed to produce the results, how to evaluate that, how to develop it, how to decide that, hey, my model is working very fine. What are the parameters? The first parameter for model evaluation and deployment is model evaluation. So you have to assess the performance of the trained model using appropriate metrics. So you can decide your features like efficiency, correctness, precision, the time taken to deliver the output. So by virtue of these all parameters, you can start evaluating your model. You can evaluate your data science model, that how effective it is for your business or how effective it is for your problem solving. So this is how you can evaluate the data model. Then model selection, how to select an appropriate data science model. See, choose the best performing model to deploy and use for the predictions. You have to select one of the models of data science which will be providing you the optimizing results. And you have to keep on assessing them. Say, for example, there are 3 ways to solve a problem. So you can pick a problem which will give you the optimal solution. This is how you can go and do the evaluation. Then model development. So integrate the selected model into the produce system for real world applications. So whenever you are thinking that, hey, I decided that this will be my model, so deploy that model for the coming data. Now, what are the futuristic aspects which are relevant to data science? See, the first futuristic aspect which is relevant with data science is big data. So big data, I think everybody knows nowadays that we are having huge data which is floating every now and then in our electronic gadgets or in our laptops, etc., etc. So all these data can be utilized to give the decisions, right? You can use AI and machine learning techniques in data science. So I already shown you some algorithms of machine learning which you can use. There is ethical consideration. Now, this is again important point in future of data science. When you're processing certain data, please be ethical. Give the legitimate authenticity to the person of which you are using the data. You can cite them, you can refer them. Also, if the data is confidential and critical, that somebody has anyhow allowed you to use the data, please preserve its confidentiality. Do not leak it, do not compromise it. And it can always promote the interdisciplinary collaboration of the research. So yes, data science is a domain which promotes the interdisciplinary research and interdisciplinary collaboration. So these are all the future avenues of data science. So let's conclude the today's discussion about data science, saying that data science is a recent trend in research and development. And as I told you guys, you cannot afford to complete your research without touching this domain. It's covers industries, R&D, educational institutions, and it's going to play a vital role even for making this world a better place to live. So thank you so much. I think I touched this big horizon of data science over here, and you all will be at least came to know that what this field is all about and how we can use this for our research. If you typically want to know that, sir, which algorithm will be suitable for which data analysis, you can always revert back to me, or we can even have discussion on this Eudoxia platforms, because they keep on inviting me in some FTPs and the STTPs. So we can even discuss these things over there as well. Thank you so much, sir, for providing me the opportunity. Thank you.